I just finished restoring a Processor Technology Corporation, California, 3P+S peripheral driver board. This board plugs into a standard S100 backplane from the 1970s, driven by an Intel 8080 CPU, such as on this IMS Associates 8080 computer, also designed in California in 1975. This is the first commercial personal computer. The 3P+S board contains 3 parallel ports and 1 serial port. All 4 ports are bidirectional. The serial port portion handles any data speed up to 9600 baud. The speed can be either hardwired or under program control. Devices such as terminals, video displays, printers, teletype machines, modems, industrial controllers can all be connected at the same time and under program control with full handshaking. This board is the peripheral input-output center of the computer. Included are support circuits for driving a relay, TTL outputs and inputs, and teletype current loops. This is the schematic of that 3P+S board. The programmable jumpers for controlling the serial and parallel ports and addressing, and interrupts. The actual input-output connectors for interfacing to the external world, and the block diagram. This took several days to sort out. I will key in a simple machine language program to demonstrate the serial port portion of this board. The program counter is now at address 0000. The first instruction will be an input instruction. D, B. I will deposit that at this address 0. The next byte will be the input port to open. It will be FF. I deposit that into the next address. FF is reserved for the front panel switches of the computer. Next, I will write an output instruction, D3, and the port to output to will be 01. 01 is the current hardwired I/O port address of the serial port on the 3P+S board. The final instruction will be a jump instruction, C3, and we will jump back to address 0000, which is a 2-byte word, 0000. Now reset the program counter back to the beginning. We can examine the program. DB, FF, D3, 01, C30000. So this is a very simple machine language program. Reset the program counter back to zeros, and let's run the program. The program is now running. Let's select for the input to write to the serial card the ASCII character A, which is a 41. And there it just started writing A's. (42), B's, and so forth. C, 3, 43. So the board is working. This is a good milestone in getting this computer up and running. Thank you for watching.